to introduce our panel. RJ Wichert will be our moderator today, so come on up, panel. RJ is a mechanical engineer at the CEC, and he was trained right here in Sacramento at Cal State Sac. He has a decade of experience as an energy analyst, and in my view, is a key participant in Working Group 1's efforts to better the state's BEM processes. So as our moderator today, I don't see anyone coming up to the stage, which panics me. Did they come today? I'm not sure. But they will explain and explore the compliance software development process and how friction in the Title 24 update cycle could be reduced by changing the way information flows between parties. You will could be benefited by having your cell phone out to get a QR code, so maybe just get that ready. Take it away, RJ.
You guys can't hide over in the corner. Okay, all right. Okay. Yeah, I think you're okay. The screen will move up too. Okay. Fair enough. All right, so let's see if I can. Cool. All right, so morning everyone, welcome to CalBEM. I'm excited to moderate this panel discussion. This morning we'll be conducting a panel discussion on the potential roles for machine readable rule sets in the energy code. Oh, okay. All right, I can talk louder too. Oh, really? Okay. All right. Cool. So yeah, we'll be talking about potential role for machine readable rule sets in the energy code update process. Some of the ways that this system could streamline and benefit the whole process. Let me go to our next slide here. But first, let me give you a little bit of background. Well, I guess with me too, we have Feng from TRC, Neal Kruis from Big Ladder, Liam Buckley from IES-VE, and Greg Collins from Zero MV, and they'll be representing different stakeholders in the process, which we'll go over in a bit here. But yeah, so the background. So what's a rule set? What's a rule and what's a rule set? So a rule is just a requirement for model inputs in the performance metric calculation, and the rule set is just a lot of rules. And so yeah, the energy code, as you all know, has a ton of rules. We have a rule set. Basically, the energy code is a rule set, and then we also have rule sets in the software as well, and we'll be kind of talking about how those can communicate, and I have a couple examples here. So, this is an example of envelope efficiency rules. As you can see, all this data, this is a manual process. This isn't a PDF, and so we would like to investigate how we could get this into a format that could be read by machines, and so. So that's the definition of machine readable. So a format that could be processed by a computer program, so it doesn't need the human interaction. And this is a perfect example of a table that could be formatted so that the software or a third-party software could easily take this in and apply it as needed. And another example, so energy recovery. This is a lot of data. One of the benefits that we're hoping with this is, airproofing. So a human has to go in and update this table. There's a lot of potential for making mistakes. And here's the CBEC implementation. So those tables that I was just showing you have to be turned into this format, which is proprietary to CBEC, and then so here's the current process. You have a rule set document like the energy code. That then needs to be transformed into the rule set that's in CBEC, which is machine readable by CBEC, and that then creates the public compliance software. And all that machine readable schemas and things are all like proprietary. Kind of the problems with this system, it's not rule set agnostic, it's not consensus based, it's not software agnostic, so third parties use different schemas for their rule sets, and it's not definitive source, and it's not schema based. And here's the vision. So you would have a software agnostic machine readable rule set in the middle there in yellow, which could then be input into the public compliance software, and also it could be feedback loops there, and then also just as easily uptaked into the private compliance software. And then it also would be able to be taken by machines and update the public, like the PDF version of the rule set. So it's human readable as well. So. All right, so on the next slide, we have a really detailed slide. So if you could try to grab I don't know if this will work, but if you use this QR code, it'll take you to a page that shows the next slide, so you can like zoom in and stuff, because there's some really detailed small text on that next slide that I don't think you'll be able to read unless you have binoculars. So. Give everyone a chance until I see all the phones are down. Did it work for anyone? Okay, cool. So thanks to Liam, he was smart to think about this idea here. All right. Cool. So I don't even know if this is showing. Yeah, I guess it's showing everything. I can't even read it here. So yeah, this is a diagram showing basically a snapshot of a 3-year process of updating the energy code. And then you can see all the different swim lanes. So you have the case team at the top, who create the case reports. You have the CEC, who's responsible for the software and the manuals, the software manuals team there. And then you have the CBEC team, so the CEC team, software and manuals. Then you have the CBEC team, so those are the contractors that are responsible for programming the software. And then you have the third-party compliance software like IES or others, who are developing their own compliance tools. And then you have practitioners who are actually implementing this. And so each of these teams has a different role in this process, and we've got like flowed arrows connecting all the different ones. And at the top, you've got kind of overall, you have like pre-rulemaking, rulemaking. You can see when the CBEC software and ACM are being developed. You can see that we have to create the CBEC software 6 months before the effective date, or 6 months, or 180 days after adoption. And then you can see the energy code effective date. And during this panel, we will be talking about all the different places that we think that machine readable rule sets could help. And so you can see we've bubbled some of the potential pain points that could be streamlined through this new system. Make sure we got the thing. Yeah, so that potential streamlining, I think I mentioned it earlier, but there's the potential for error reduction, and it's automated, so there's less human work, so it takes less time to move the rule set from one place to another. And then other codes too that I forgot to mention that we would need to coordinate with, so ASHRAE 229P, rule set model description schema, and ASHRAE 232P, the common content and specifications for building data schemas. Those are other codes that we'd want to coordinate with if we wanted to implement this. Yeah, so I think we'll switch it over to I'm going to leave this slide up, and we'll go through our panelists' with a few questions, and we'll kind of, as we go through this, we'll start at the top and kind of work our way down with each question. Okay, so we'll start with Dove here. Yeah. Yeah, actually, yeah, it's a great idea, Neal. So yeah, Dove, do you want to start us off? Yeah. Yeah, I think we're gonna. Yeah, let's move around. Yeah. Yeah.
It's easier.
Sure.
Yeah. So hi everyone. My name is Feng. I'm very glad to be here and representing the.
Oh yeah, I think you have to use
this one. Representing the case team here. If I may ask for a show of hands here from the audience, how many people are part of the case team, the statewide case team, which stands for Codes and Standard Enhancement Initiative? Great. There are many people involved in those process to develop code change proposal. I am going to move to the next slide. Okay. What is the case process? So usually when the code most of the code changes start with the code process, which is a research and gathering of information to provide the document that support the rulemaking process. And a very big part of that includes energy analysis of those proposed measures. And the energy analysis impacts and development of the algorithm that can actually predict the performance of the proposed measure. So how do we do that? Energy saving analysis, there are many options. There are several options, so depending on the method, depending on the measures we're evaluating, there are several options, usually several options. There are three I have used or are aware of. The first one, most of the people will use just modify the existing rule sets. Usually that's the kind of measures where the software is already available to model the measure. So for example, the example RJ was showing earlier for the envelope U value. So if we're proposing increase of the stringency of the U value, you can model it. You can model it in different wall types in the software and evaluate the energy performance and etc. There are other measures where the software does not have the ability to model them. For example, heat loss and the hot water pipes. For those kind of measures, it's hard because, like for example, Energy Plus, which is the engine for commercial building simulation, it doesn't model heat loss in the pipes. And California Simulation Engine, which is the engine for residential building, it has the capability, but there are a lot of limitations. So what we have done before is to use some spreadsheet models developed and it used heat transfer fundamentals to capture the heat transfer and predict the energy impact if we're increasing the insulation of the pipes and allow us to evaluate the configurations we would like to evaluate and analyze the energy impacts. The third option, a lot of those use lab testing data for those measures where we cannot predict, not modelable or hard to model. Like for example, heat pump water heater ventilation approach in the 2025 code cycle. One of the measures we evaluated is what is the impact of the heat pump water heater ventilation approach and how does that impact the COP of the heat pump. So anyway, those are some options. Once we collect all those data and come up with some algorithms to evaluate the energy impacts, we generate the case report. And in the case report, there are a lot of contents directly support the rulemaking process and the rule set development, right? So ACM, everybody's familiar with ACM, includes all the proposed model inputs and algorithms for predicting or the protocols for how do we model the standard design, how do we model the proposed design. So all of those contents are included in the case report. So the case team have to produce those content. Oftentimes, the collaboration, once the case report is generated, we would work with CBAC software team to make sure whatever we're proposed in the case report can be implemented. The bigger goal is you want it to be able to show that the predicted energy performance from the case report should align with the performance prediction from the CBAC software, which is going to be implemented or developed like 2 or 3 years in the next 2 or 3 years. So there's potential in misalignment or inconsistency between what the case report is predicting versus what the software is predicting if there is not that coordination happening. So how would the machine readable rule sets help with this process? I think we can talk about that a little later, but at high level, because the case team needs to be able to do the energy analysis, so it's really important for them to understand what is actually modeled in the software, what is happening, and what are the algorithms that's currently implemented. I think with machine readable rule set, we'll make all those information a lot more easier for the case team to have access to those information and also just reduce the human error in the process. I'll just leave it there and we can definitely talk more later. I'll turn over to the next panelist.
I guess that's me, I suppose. Or yeah, actually, so Neal, you would be next, right? Yeah. Okay. Yeah.
I'll just quickly go.
Yeah.
Test. Can you hear me? Okay. Great. So, all right. So I'm representing the CBAC team. I work mostly with Kruis Wilcox on the residential side, but did run this by the Maresco team as well earlier last week. And so one thing that I want to just point out in this whole diagram is that the time scale here is not exactly linear, because what you see happening from kind of the beginning to this approval phase, that's actually like 2 years. And the rest of this happens in the last year, maybe. That's maybe generous. So all of this stuff to the right has to happen after all the rulemaking, all the workshops happen over the course of several years. And so the experience on the software side, and this is all kind of dynamic. It's changing every code cycle. I think we are making improvements. But what happens is we get these reports from the case team, and it's kind of at the end of their contracts for what they have to do. They kind of lob it over the fence to the software team and say, hey, implement this. We've gone through a couple examples of how we think it should be implemented without knowing the details of the software. And so the software team gets these code changes, and they have to decide, all right, can that even be supported by the engines we have? And if not, we might need to make engine source code changes, and then ultimately interpret it all into CBAC, and not just the cases that were studied in the case reports, but also what if you combine this system with this system, then what happens? And all these edge cases that aren't always easily thought of in the process of developing the case report. And so this is kind of where you have feature interoperability in the software is a really important thing. You can't just have something that only works in this scenario, right? So we have to consider all the scenarios. And then throughout this process, actually this box here, this beta version, one thing to point out is that there's always a research version of the software that's available. And I think that's an important thing that we don't really highlight enough, is that people can look at that, and if you invest a little bit of time into understanding how to get the latest version, you can test things as they're kind of coming out. That doesn't necessarily mean that they're going to be in the software, because sometimes we're testing things that we decide to not put in the software. But that green software, that green box really kind of it's always going. Right now there's a research version of the 2025 software that people can start looking at. And then we go into, once we're near the end here, we have software testing. Once we think things are pretty good, we talk to the Energy Commission and say, okay, now we're probably ready to certify the software and the ACM manuals. I guess that's another point here, is that the software and the ACM, the idea is to have the ACM ready beforehand, but that's not the case, right? We're making changes to the software, and then that change needs to be propagated back to the ACM. And kind of going back and forth. So we have a lot of interaction, and then finally we arrive at this case, at the point where the Energy Commission can certify the software and publish the manuals, and then we can release the software to the public. And then at that point, we kind of say, okay, here's the software, we lob it over the fence, and then the next group comes up, the third-party software can kind of look at that and then start their process. And so part of this, the challenge in this process is like, things are just getting lobbed over the fence without a whole lot of interaction. Like I said, that's being improved continuously, but we're looking at ways to improve that further, maybe with machine readable rule sets, but also just logistics and communication and things like that. So I think that's all I have to say. I'll leave it at that.
Thanks. Hi everyone, I'm Liam with IES and I'm representing this swimming lane here. So I just wanted to talk about three things. First, my impression of this kind of crazy diagram. Second, why I'm up here. And third, machine readable rule sets. So within these swimming lanes, which is a great analogy, I think, so thanks, Michael, for coming up with that. You know, allegedly, we all jump into the pool at some point, not at the same time, clearly, moving from left to right. So I wanted to give two more analogies, one being somewhat similar to a psychrometric cycle of air moves across a cooling coil and then into a room. At some point, that air leaves a room and makes its way back to an air handling unit and subsequently a cooling coil again. That's a cycle. The name of this diagram is the Title 24 code, cycle. Notice there's nothing connecting any of the endpoints back to the original starting point. So to be constructive, I think my first recommendation for this cycle is to complete the cycle. Just even listening to Dove speak about this, I had no idea what the case team do. I have no idea how their teams are formed. I have no idea how or why they decide to work on what they do. I also listened carefully to her describe things like CBEC, Energy Plus, CSE. What was not mentioned was compliance software, which is what the ACM is supposed to be for. And you know, we're representing this swimming lane as a compliance software. The second analogy I think I'd like to draw attention to would be that, you know, obviously we're all in these individual swimming lanes and we can't really start at the same time. And subsequently, some of us are actually acting as a relay race, whereby we cannot begin until somebody else can hand off the baton to us. And there are two particular use cases for that. There's the public domain software and the private domain software. Notice, I'm not too sure how the colors are coming across, but if you can see the green, or the two little red circles, that's our finishing point for these two lanes. Sorry for moving away from the mic. And we both start with a green little bubble. But notice there's a large time sink between the two swimming lanes. So we don't start at the same time, we don't finish at the same time, and that's a bit unfair. So my second recommendation is for the CEC to establish a formal certification process that is fair and equitable. And indeed, California's Warren-Alquist Act calls for an equitable and timely certification application. The second thing I want to discuss was why I'm up here. So I was a little late to join this party. I think we have, well, I attended 3 meetings to help prepare this diagram. I don't know how many meetings were ahead of that. It looked a lot different when they started. And originally, the two little red bubbles were basically on top of each other. So the notion was, oh yeah, the software tools will just drop in rule sets and it'll be good to go. And that's not how it works at all. There's a lot of speculation that happens ahead of time, a lot of work that has to go in ahead of time, both working on very different timescales. So, you know, we were grateful for, let's say, for example, the 2019 code cycle that the CEC allowed us to use our own simulation engine for Title 24 code compliance, which was an alternative simulation engine, provided it complied with ASHRAE standard 140. So in theory, this could mean we actually achieve 2 goals. Number 1, we can help the Energy Commission accelerate their goals of carbon neutrality and to continue to decarbonize the built environment. And number 2, and more importantly to us, is to give the AEC, a practitioner, the integrated tools that they so desire. And finally, the last comment I wanted to make was on the machine readable rule sets. So I made some notes here. When we discussed this internally with our software development team, I wrote down some notes of their initial responses, and they were as follows. This idea is brilliant. I love this idea. This would be awesome. This would be super efficient. And then finally, this sounds too good to be true. And we sort of hung on that last one for a while because, you know, this is something the Energy Commission should definitely consider. Like, we're definitely in agreement of that. But when the practicality sets in of what this actually means, you know, reading rules and processing rules is a very different process, and it's a complicated endeavor, and that's primarily because the data model is very different in one compliance software tool as it is to another compliance software tool, and any software engine for that matter. So because of the magnitude of that project, I think our final recommendation is not, you know, just being practical here. I don't think creating machine readable rule sets is quickly achievable. So what I would recommend is to nugget off basically smaller projects where we could somehow automate smaller optimization projects or smaller automation projects. So, you know, keep the data files as separate as possible from the actual rules themselves. Use standardized formats, so XML or JSON, and just carve out small little automation projects rather than go for the whole hog of machine readable rule sets. So that's me. Thank you.
Thanks, Liam. I like those ideas of getting the low-hanging fruit first, you know. All right, great. Wow.
Hi, everybody. Greg Collins with IES-VE. We're an energy modeling consulting firm based in California, representing the practitioners swim lane here. How many practitioners do we have in the room? Like, you working on design projects? Awesome. Cool. It's a big contingent this year. So most of us, I think, at least I know me personally, I get involved in this process right here. The bottom corner is, you know, using the tools, the publicly developed tool or the third-party tools. We use both. And I know we kind of have the opportunity to jump in the pool sooner. I personally haven't done that, so I know I'm invited. I know I review the newsletters and try to, you know, put the full-day workshops on my calendar, and, you know, hardly ever. I think I joined one once for 30 minutes, but yeah. So I don't know. My involvement ends up down there. Do other people like have the opportunity to join sooner? Some of the people that raise their hand. Gina, awesome. A couple back here. Yeah, cool. So that was much, you know, a lot fewer hands in general, but still some hands. So glad you're providing feedback. I guess another reason I joined this panel is my interest in the machine readable side of things. So just as a way to simplify, I think Liam did a good job with the feedback. So I don't know, I would agree with a lot of that. We developed a website called the BEM Toolbox. So my team has started, we started learning Python coding a few years ago, and have started trying to create this, well, we've created this platform to share those tools with other energy modelers, not California compliant software specific, but I like to say you know, well, I appreciate a lot of like the machine readable aspects in the envelope table slide that was up here before. Like, you know, we've put that into spreadsheets and lookup tools, and, you know, are trying to automate that, but just like, I think that's a good example of, you know, all these merged cells and I don't know, having to parse that, like there's a huge opportunity. That's like one small example. But anyway, a little background. We'll jump into the panel now.